Hi guys, so we're now on learning target 3C, which is linear inequalities. Okay, so we've already explored linear inequalities a bit, but today we are officially going to learn how to determine or find solutions of linear inequalities in two variables using a graph with the xy plane, and how to construct linear inequalities given constraints and in the context of real-world applications. Okay, so let's get started. Okay. So a solution to a linear inequalities, right? So we've already learned how to graph lines. So just as we can graph lines, we can also graph linear inequalities. Okay. And a solution to an inequality can be thought of in two ways. One is algebraically, and the other one is on a graph. Okay. When we're talking about algebraically, a solution is where all points that make the inequality true. Right? So if this point makes the inequality true, then it is considered a solution. Right? When we graph a linear inequality, okay, the solution is all points in the shaded region. Right? So just like when we graphed on a number line, we shaded all of our solutions. The same thing, this time on a graph with our x and y axis, right, and on an xy plane, all points in the shaded region are solutions. Right? So how do we graph linear inequalities? First, we are going to rewrite the equation. We've learned how to do that in almost slope-intercept form. Okay? Unless it's a horizontal vertical line, then it's not in a slope-intercept form. Okay? The reason why I say almost slope-intercept form is because we have an inequality symbol, okay, instead of an equal sign. Right? So that's why I'm saying almost slope-intercept form. Okay, and if you remember, we do this, okay, by solving for y. Okay. Okay, so after you are done rewriting the equation in slope-intercept form, then you're going to graph the line, okay, using its type. Okay, it's going to be a solid line, so something like this. Okay, it's going to be a solid line if you see the symbol less than or equal to or greater than or equal to. Okay. The reason why is because the solid line means that it's included, right? Similar to our closed circle. Okay, it's going to be a dashed line, okay, if you see a less than or a greater than. Okay, kind of like our open circle, right? So the solid line means that that line is included, it's equal to. Okay, the dashed line means that those points on that line are not included. Okay. Then afterwards, okay, we're going to shade one side of the line. Okay, so either above or below. Okay, we're going to shade above whenever we have y greater than or y greater than or equal to. Right? If you think, right, above, when we're talking about up and down, the y values that are above are greater, and the y values below on the bottom part of our graph, these are less than. Okay? Okay, so if it's above, we're going to shade above when it's y greater than or y greater than or equal to. And we're going to shade below when it's y less than or y less than or equal to. Okay? And then just to make sure that we shaded correctly, we're going to check a test point from the shaded region. Okay? So let's get started with our first example. Okay? So I want you to think about the inequality y less than 2x plus 3. And we're going to graph it. Okay? So the first thing, we're going to solve the inequality for y. Okay, that's already done, so we're good. We can move on to the next one. Okay, so the next part tells me to graph the line type. Okay, we've learned how to graph lines, right? So this here is my y-intercept. It's my b. Okay, so that's what I'm going to start with. Okay, so my y-intercept here at 3. Okay, and then this here, this 2 is my slope. So this tells me I'm going to go up 2 and to the right 1. So I'm going to go up 2, 1, 2, to the right 1. And then make sure your line is accurate. So some people do points all along, right? Just to make sure it's a little bit more accurate. Okay, I can already see, right? I was a little off here on the up to right one. Okay, so again, the further and further we get from our main points, okay, it's gonna be, okay, and look, I've already made a mistake. Right, so here, the line type, right, if we remember, it's either going to be solid or dashed. Okay, because this is a less than, okay, that means the line is not included. It should actually be a dotted line. Okay, but here you see that I drew a solid line. Okay, so this happens sometimes, right, and it happens on the quiz or homework. Not a big deal, right? If it was in pencil, you can erase little parts of it. Okay, but since like this, I wrote in pen, not a big deal. All I'm going to do is mark that it should be dotted, and that will let me know that this is actually dotted, it's supposed to be dotted. Okay. So please be careful. You already saw that I made a mistake, right? So this, it should be a dotted line because of this symbol here. Okay, and so I made a mistake on a solid line, so I would erase it if it was in pencil. This is why we do math in pencil. Right, or white it out or something, right? Or you can just give me a note that that should be dotted. Okay. Now we're going to shade either one side of our line, so either this side or this side. Okay. Because it was a y less than. Okay. So if you think our y values that are less than, they are below. So I am going to shade below my line. Going to shade it, the whole thing, right? So some people do it in pencil where they shade the whole thing, right? Okay, so since it's y less than, I'm going to shade below because all my y values that are less than, that are smaller, are below. Okay. Then, just to make sure we did it correctly, we're going to pick a point in our shaded area. Okay, it doesn't matter which point you pick. It could be this point, it could be this point, it could be this point, it could be this point. I like to use 0, 0 as my test point, okay, if it's in the shaded area. So I'm going to pick 0, 0. That's in my shaded area here. Okay, and all I have to do is plug it in for x and y in my equation. Okay, so I'm going to do 0 is less than 2 times 0 plus 3. Okay, then 2 times 0 is 0. 0 plus 3 is 3. Is 0 less than 3? Yes, it is. So I did shade the correct area. Okay. So let's try the next one. Okay. So here I have 2x minus 3y less than or equal to 6. So the first thing I need to do is I need to change it into slope-intercept form. Okay. And I do that by solving for y. Okay. So I'm going to first subtract 2x. Okay. So negative 3y is less than or equal to negative 2x plus 6. Okay. I still need y by itself, so now I'm going to divide by negative 3. Remember, when you divide an inequality by negative, you need to flip the sign. So this less than or equal now becomes greater than or equal to. Okay. Negative 2 divided by negative 3 gives me a positive 2/3. So positive 2/3 x. And then 6 divided by negative 3 is negative 2. Okay. So this is now my new inequality. Then I'm going to graph the line, okay? So this time I'm going to be more careful. Okay, because this is greater than or equal to, this is a solid line, okay? And the reason why it's solid is because I want the line, this line is part of the solution, okay? So let's get graphing. Okay, so I'm going to start with my y-intercept, which was negative 2. Then, using my slope, I'm going to go up 2, right 3. So, up 2, right 3. Okay. And then, all I need to do is connect. But just because mine was a little off last time, I'm going to keep going throughout my whole graph. Up 2, right 3. Okay, also the other side. Okay. That way it's a little bit more accurate if I do points all throughout. Okay, and then again, it's a solid line this time because it is included as part of my solution. Okay, it's solid because of that equal to. Okay, and then now I have to shade a half plane. Okay, because it's greater than, okay, it's y greater than, right, I'm going to shade above the line. Okay, that's because all the values that are greater for my y's are above. Okay. So all I have to do is shade, shade, shade. Right? And then, just to make sure we did it correctly, we're going to pick a point and plug it in. Okay, so here, I'm going to pick a point. I'm going to pick any point works. Okay, I'm going to pick, let's do 3 comma. Let's do 3 comma 2. Okay. So I'm going to pick the point 3 comma 2 and I'm going to plug it in. Okay, so it says to plug it into the original. Okay, it technically doesn't matter. Okay, but I'm going to do it for both. Okay, so I'm going to do it here. This is x and y. So I'm going to do 2 is greater than or equal to 2/3 times 3 minus 2. Okay, this is the new equation I did for the slope-intercept form, and then I'm also going to plug it into the original. So 2 times 3 minus 3 times 2 less than or equal to 6. All right, so all I did is I took the x and y and I plugged it into the equation. Okay, it says the original. You can also do it with the other one. Okay, so 2 greater than or equal to 2/3 times 3 is 2. 2 minus 2 is 0. Is 2 greater than or equal to 0? Yep. Okay, and then just in case I changed it wrong, I want to also do it for my original. So 2 times 3 is 6. Negative 3 times 2 is negative 6. Okay, here I got 0. Is 0 less than or equal to 6? Yes, it is. So I did shade in the correct part. Okay. And then I just want to do it one more time, but this time I want to just show that these are incorrect. Okay, so I'm going to pick another point. Let's say I pick this point here. It's not shaded. I'm going to pick 0 comma negative 6. Okay. I'm going to plug it in, okay, to show that it is not a solution. Okay, so I should get a false statement. Okay, so plugging this in, negative 6 greater than or equal to 2/3 times 0 minus 2. I'm also going to do it to the original. Okay, and I should get false statements. False statements. Okay. So here, 2/3 times 0 is 0. Okay, and 0 minus 2 is negative 2. Is negative 6 bigger than negative 2? Nope, it is not. Okay, and so that's why you see that it is not shaded here. Okay. And just to check, 2 times 0 is 0. Negative 3 times negative 6 is positive 18. Okay, and I have 18 less than or equal to 6. Is 18 less than or equal to 6? No, it isn't. And that's why you see that that point that I just checked is not in the shaded region. It is not a solution. Okay. Okay, I'm just going to do one more for us here before we talk about horizontal and vertical lines. Okay, so again, I want to solve the inequality for y first. Okay, so I want to do it slope-intercept form. Okay, so changing it into slope-intercept form, I need to solve for y. Okay, so subtract 4x. I get y less than or equal to negative 4x minus 2. Okay, then I need to graph the line type. Okay, because it is less than or equal to, okay, because of that equal to part, it's going to be a solid line. Okay, and then because it's y less than or equal to, I'm going to shade below. Okay. So let's get graphing. Okay, I'm going to start with my y-intercept, which is here at negative 2, my b. Okay, then using my slope, I'm going to graph the next point. So since it's -4, I'm going to go down 4, 1, 2, 3, 4, and then to the right 1. Okay? And then just so it's a little bit more accurate, I'm going to keep going throughout. 1, 2, 3, 4, 1, 1. Okay. Again, because of that equal to, it's going to be a solid line. Okay. And then because it's less than or equal to, I'm going to shade below. Right. Then, just to test my shading, I'm going to pick a point. Okay, any point works. Any point that is in the shaded area works. Okay, you can pick any point you want. Okay, so let's pick this random point. Let's do -5, -4. Okay. Like I said, any point works in that shaded area. You could have picked a different point than me. I chose -5, -4. Okay, I'm going to plug it into both of them. This is my x, this is my y. Okay, this is me plugging it into the slope-intercept form. And then just in case, I also want to check with the original. Okay. So -4 times -5 is 20. 20 minus 2 is 18. Is -4 less than or equal to 18? Yes, it is, right? That's why it's in the shaded area. Okay. And I'm just going to check again. 4 times -5 is -20 plus a negative. That just means minus. Okay. -20 minus 4 is -24. Okay, is -24 less than or equal to -2? Yes, it is. Okay. And then that is why it's in the shaded area, so I'm good to go. Okay, right. So what happens if it's not in slope-intercept form? What happens if it's just a horizontal and vertical line? Okay, those ones are even easier. Okay, so here I have y greater than -4. Okay. When it's y and just a number, this is a horizontal line. Okay. And then because it's greater than, it's going to be dotted, right? Because it's not equal to. And then greater than, I'm going to shade above. Okay. So here at -4, okay, I'm going to make my dotted line. Boop, 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 boop. Okay. Arrows. Okay, and then if you think about it, where are the y values bigger than -4? Right here. Okay, so then I would shade this whole thing. Okay. Right. And here's the next one. Whoa. Y less than or equal to 2. Because it's less than or equal to, the equal to makes it solid. Okay, and then because it's less than, y less than, I'm going to shade below. Right, because here is where all the y values are less than 2, right? Y value 1, 0, right? These are all less than 2, so that's why I'm shading below. Okay. So then these last two, okay, this is a vertical line, right? X and then just a number, X just a number, this is vertical. Okay, because it's greater than or equal to, that's going to make it solid. Okay, so I'm going to do my solid line at -4. Okay. And then where are all the x values that are greater than, bigger than -4, right? So that's on the right. Okay, so then all I have to do is shade to the right. Okay. And then less than 2 here, this is going to be dotted because there is no equal to. Okay, so x less than 2, make sure it's dotted. If not, erase or white out or mark that it should be dotted. Okay. Where are the x values that are less than 2? The x values that are less than 2 are to the left here, so that's why I'm shading to the left. Okay. So that's it. I'm going to have you try this one on your own. Solve the inequality for y, graph the line type, shade a half plane, and then test a point. Okay, and then come back, check your answer. Okay, so this is what you should have gotten. You should have first solved the inequality for y by subtracting x, and then getting rid of this 5 times by dividing. Your final answer should be y greater than negative 1/5 x minus 2. Okay. Because it's greater than, it's y greater than. Okay, it's not equal to, so that's why it's dotted. The line is not included as my solution. And then because it's greater than, we're going to shade above. Okay, since it's y greater than, y values that are bigger are above. Okay, so I graphed with the y-intercept of negative 2. Then using the slope, I go down 1, right 5, down 1, right 5. Okay, connect my dots. Okay, and then shade it above. Okay, then you should have tested a point. Okay, it's any point in this area. Okay, so you could pick this, any random point that's up here. Okay, you plug it back in. Okay, and then it should be a true statement. Okay. That's it for today. Have a great rest of the day. Bye, guys.